Hello friends, welcome back again to Systematic Automation. This is my third session and last session probably on comparison between Siemens and Omron PLCs. So what we will do is we'll go back to our program of timers. So this is my TR portal. And let's open CX program as well. So let's start with CS program. I will define IO comments. I'll use input 0 to start my off delay timer. Let's say on delay. Then 01 is for off delay. Then I'll go to 100. The two outputs 100. This is my on delay motor, off delay motor. Section I will put one no contact for to start my on delay timer, right? So I'll put it as 0.0 on delay and a timer which is going to be TIM 0 hash 50, that is for 5 seconds, right? I will not name it. Then I put one more no here with no with timer 0. I'll start my output coil 100.0. This is on delay coil, right? Then I will use one more no contact here, which is going to be 0.01, which is off delay. Okay, let's see how this works first for you to understand. Now this is my on delay timer simulation, work online with simulation. Right. So if I force it, the moment I start, right, on, this motor will come on after 5 seconds. Clear? This is what we did last time. After 5 seconds, this motor came on. So we will do same with TR portal, no, okay. Before that, show all tags. I will say on delay, which is going to be my I0.0 of delay, which is going to be 0.1 on delay motor of delay motor. Okay, so these are going to be Q 0.0, Q 0.1. So in the program, let's say on delay, with on delay, I want to start a timer instruction, timers and counters on delay. Okay, this is going to be my 5 second on delay timer. Once timer elapsed, I want to start my on delay motor, right? So my simulator is on already, only I have to download this. load and monitor. Now force, watch table and force, go here, force table, split this. So what I need to do, I 0.0, I 0.1, right, on delay and off delay, play. The values should be true, true. So now I can force one by one. We'll do only one. Force. Yes, this is on. After 5 seconds, this motor goes on. Right? Remove force. Yes, force is removed. The timer went off. Same thing now. I will remove this. The moment I remove force, the motor went off. Now this is on delay. How about off delay? What is off delay? When I switch on the input, the motor should come on instantly. The moment my input is on, the motor is on. When I switch off the input, the motor should go off after a delay. That's called off delay timer. This is on delays. When I switch on, after delay, the motor comes on. The other is off delay, is when I switch off. From switch on to switch off, the motor should go off after the delay. Let's see this in TIA portal first. In TIA portal, what I'll do, I'll put one no contact here. This is going to be my off delay, right? That's my off delay timer. Then in timers, there is something called T off. I'll click on T off. So this is my 5 second again. 5 second. And output, which is off delay motor, right? So download, load. Okay. So now let's force this. I'll remove this force. I'll keep only this force. See now, see how it works. The moment I start input, my output is on. The moment I start this input, my output is motor is on. When I remove the force, that means when I switch off the input, see what happens. When I switch off, the timer starts timing, and after 5 seconds, this motor goes off. That's why it is called off delay timer. Hope this is clear. The moment I switch on, the motor comes on. The moment I switch off, the motor goes off after the set time, which is 5 seconds. Done? That was simple in TIA portal, but in Omron, this is slightly going to be tricky because we do not have things like off delay and on delay timers in this. With the help of on delay timer itself, we'll have to create a off delay timer. How do we do that? Okay, this is my, oops, I have to go simulation off, and then I put my no contact. This is 0.01, which is off delay. Once my off delay is on, I will switch on my output, which is 100.01 off delay motor, right? So what will happen? The moment I start this, the motor comes on. But it should goes off after some time. For that, what we have to do here, I'll put one NC contact, normally closed contact, which is going to be again 0.01. Same push button, off delay push button. Then I will start a timer here. Timer tim 1 hash 50. 5 second timer number 1. Now we have to put some interlocks here. How to put the interlock? What I should be doing? This output should goes off after this timing is done. For that, what I have to do? I have to put a NC contact of timer 1. Right? So NC contact of this timer, and in this one I have to put NO contact of this output 100.01, and then this off delay I'll have to hold it, latch it. So I'll put a latch on this. This is going to be 100.01, right? So this is the logic to make it work as a off delay timer, right? Let's see. Work offline. Right. So force on. See, once I force it on, my output, the moment I started this input, my output latched to on all the time. Now what happens when I switch off? Say same button NC I'm using here, right? So when I switch it off, force off. See, now the timer started timing. After 5 seconds, this contact becomes open. You did not see it, but it opened up for a few fraction of second, and my output went off. Right? Similar to this. Right? Force on. The output went on. When I switch it off, force off. This motor goes off after 5 seconds. Right? Same way, when I input on, force on, the output came on instantly and stays on. The moment I toggle it from on to off, the timing start. 1, 2, 3, 4, 5. After 5 seconds, this output went off. So this is the way of doing on delay timer and off delay timer. Hope this is clear to you all. On continuation of this one, what I will do one more function, which is my counters. Right. So for counters, again, what is a counter? A counter is a command which counts the number of times the input is activated. There are two types of counters, count up and count down. So when I do count up, it keeps counting up and how many times the input was pressed. So let's see this in TIA Portal, because this is much simpler in TIA Portal. So I use I 0.0, how many times I pressed on delay timer. Then I'll go to instructions, I'll go to counters. See, there are three types, count up, count down and this is count up down, combination of both. So let's start with count up. Right, in this I have to give the preset value. For example, if I give say 3 counts, what happens after I switch on and off this one for 3 times? My output will come on. Say I'll say some Q 0.2. So one of my output I wanted to come on once I press this 3 times. Right, let's see this. So what I'll do, Q 0.0. So I'll toggle these 3 times. See, on. So this is one time on. So my output is still off. I'll go off, then on again. I counted 2. See this 2? I pressed it 2 times. Then I go off again. Yes. Then I'll press again 3rd time. When I pressed it 3 times, my output went off. This is straightforward count up. Okay. Now let's go to this one, how to add counters here. So again I will use no contact. So I'll have to stop simulation. Right? To stop simulation, see there is one shortcut here also. I can click on shortcut. It will stop the simulator. Then I'll put no contact here. I'll use 0.0. This is on delay. Then in this I'll put counter here. How do you select the counters? Go to details, find instruction. In the instruction where timers and counters, I'll choose this. There are different types of counter: reset timer counter, reset time counter binary. So for now I will use counter alone. Right. This I will name it as 0, counter number 0. So this is still showing me some red mark here. What I need to do, counter 0 hash 3 times counting, right? So this counts it 3 times. So let's see this for simulator. It is giving me error because it is looking for this input also. So I'll put one input here, and this is going to be 0.01. Oops. Control Z. I'll put 0.01, and then I will use this connect line to connect it to this. Now let me start the simulation. Right. Force on. This became 2. From 3 it became 2. Then force off, force on became 1. Force off, force on, it became 3. So the output became on. I did not put any outputs here. So let's do the outputs also here. What I will do, one NO contact here, C0. Then output, I'll say 200, which is my memory. Now you can put output also 100.02. Right. So I will start my simulation again. See, this has counted already 3 times. Before that, I have to reset it to 0. Force on. So the number went back to 3. Right? So off. Do it 3 times. Force on. Force off. That is 1. Force on. Force off. 2 times. Right? Watch this. Force on. See, third time I pressed it, this became on. So force off. Right? This will stay on as long as this BCD number is 0, 3 and 0. So to stop it, what I have to do? I have to reset it. Force on and force off. See, usually, can you take a guess, like these counters are used with, timers. Timers can be used to start some motors or lamps. For example, at your home, you wanted to start any lamp. After you press the button, it should come on after, say, 5 seconds or 10 seconds, right? Or once you switch off the button, the light should stay on till you go out. So once you start it, the light should come on. When you switch off the button, the light should stay on till you go out of room. So say it will take 10 seconds for you to go out of the room. So you set the timer as 10 seconds. The moment you enter the room, you switch on the button, the light comes on. When you are leaving the room, switch off the button, the light stays on till for another 10 seconds. That is the time you need to go out of your room. So that the light goes off automatically after 10 seconds. That is the application of your timers. What about the counters? Like if you have a classroom and you wanted to count, or say shopping malls. In the shopping mall, you wanted to count how many people have entered the main gate. So what you do, you keep one proximity sensor on the main gate. So the proximity sensor will activate the counter every time a person passes across this proximity sensor. So you will have a number of counts. So for example, in a theater, you keep a proximity sensor on the main gate. It will keep counting number of people enter the theater. The moment the number of people who have entered the theater exceeds the set limit of say 3 or 100 or 200, the moment it reaches to 200, your output will come on, and with this output you can display a sign on the front of the main door saying house full, right? So when the capacity of the theater or auditorium is full, which will be counted with the help of a proximity meter and a PLC program with the counter. So it keeps counting how many people have entered the theater. So the moment it reaches 200, you will have a display on your main gate saying house full. So these are the basic kind of small example of what is the use of timers and counters. So I will take this application in actual PLCs and show you how to download this. So let's do this function of checking all the functions online with your physical PLCs. So we will start with the actual physical PLC of Omron first. So this is our setup wherein we have various types of PLCs. Like we have Siemens PLC here. This is our Siemens PLC controller, SM1200. Then we have ABB controllers. Then we have a Rockwell. Then Schneider PLCs, two different types of Schneider PLCs. Then Delta PLC. Then this is the Omron PLC on which we are working right now. So this is my Omron, then two Delta again. So three types of Delta PLCs, two Schneider, one Omron, Rockwell, ABB, and Siemens. We have multiple Siemens products here. So to start with now, we'll go to Omron, download the program in Omron and see how our actual program works on physical PLCs of Omron. Okay, so I'll zoom it to Omron PLCs now. So this is my Omron PLC, right? So I have connected a comms port. This is my USB comms port here, and then I have inputs and outputs. So this is powered up now. So this comms port is connected to my laptop. So now the same program we will download it to my PLC, which is Omron PLC. So how to download this? We'll see this session first, how to download the PLC into Omron PLC. So to do that, what I have to go, first I'll have to do work online. It tells me about to connect to the PLC, say yes. The selected port does not exist. It says the selected port does not exist because I did not connect my USB here. So I will connect my USB to my laptop. So now the USB is connected. PLC, work online, say yes. So now this is my PLC connected. See, there is whole old program running on this PLC. If I have to make this functioning, what I have to do, I'll have to download this program into my PLC. So what I have to do, PLC transfer to PLC. If I do transfer to PLC, say OK for this. This command will affect yes, say yes, say yes. Now my PLC, this particular program is running on my PLC now. Now let's do one by one. So the timer, the off delay and on delay timer, what we have written. So if I press this button, I have a push buttons connected on my PLC. If I press this button, my timer will start. See, the moment I press and hold it, my timer starts. After some time, the output goes off. The moment I leave my input, right? So my off delay timer should start now. Let's see. So this off delay timer, I did not connect my one more input here. So for now, what I will do, I will force it. Force on. Force on. And then I'll remove the force force off. So that's the time the timer starts. My output comes on here. See, after some time this output goes off. Like again, if I do force on, my output is on. Once I remove the force off, my output will go off after some time, right? So this is home run. Now we'll see the counter function also. First of all, I'll remove all force, remove all force, cancel all force. So all my force are gone. Now let's see the counter. So this will count from my inputs. So let's see. So I will press this button 3 times. Okay, that is 1 time. So my counter became 2 now. 1 more time, the counter became 1. The 1 more time, so my output came on. To reset this output, what I need to do, I should be pressing this button, but I don't have that button connected now. So I'll force it on. My output went to off. So I'll force it off. My input is gone. So this is pretty much what is my physical PLC working on the PLC, on Omron PLC. So now we will see same thing on TIA Portal Siemens PLC. Alright, so what we will do, we'll go to Siemens PLC now. So this is my Siemens PLC S7-1200 PLC with inputs and outputs. Everything you can see it here now. So going to the program now, TIA Portal. So now I'm not working with the simulator. What I'm working with is my actual inputs and outputs. So if I go here, so for this what I have to do, I'll have to download this program into PLC. So what I will do, I will go here, I program, right click, download to device, hardware and software. Now it is searching, so I am connecting it through Ethernet port. So what I will do, I will start search. So this has found one PLC here, controller. So I will download this program into my controller. Say OK, say yes. This is looking for the IP address, auto IP. Okay. Continue without synchronization. To stop all, my PLC will go off, load. See, the PLC is in off condition now. Right, now it's start model, watch this LEDs, this goes on. Right, now I can monitor my online program. So on the network one, what I have is on delay timer. So the moment I press push button 1, 0.0, press 0.0, the timer will start. After some delay, the output will come on. The outputs are here. See, the output has come on. Okay, stop it. If I stop it, the output goes immediately. The second one is off delay timer. The moment I start I0.1, see, the output has come on. See, that is Q0.1. When I switch it off, it will go off after some time. Switch it off. So it is still on. After 5 seconds, this goes off, right? So now same way counters. This is my count up. So I'll have to start. So what I've done is I've given, if you see here, I have connected this proximity sensor to input 0.0. That means whenever I activate this proximity sensor, the input goes on and off. This is this will detect, once we detect a metal here, the output starts coming, toggling. Let's see. So if I say toggle one time, touch the metal one time, see the input came on here, it counted for 1 here, 2, 1 more. So once 3 counts are done, my output Q0.2 is on, right? So if I have to reset it, what I will do, I'll put one reset button here. So I 0.4 or 3 I will give, I 0.3, then download the program. And then monitor. If I press I 0.3 now, the output goes off. See, once I press I 0.3, the output went off. Then again, if I give 3 pulses, after 3 pulses, Q 0.2 comes on. So we'll give pulse 1, pulse 2, pulse 3. After 3 pulses, the output came on, my LED here came on. So this is the way my physical PLCs are actually working. So on this session, this is what is basics on timers, controls and all in third session. So you have seen we have multiple number of PLC controllers, and I will show you some VFD controller also. We have some VFD controllers also. I'll show that VFD controllers also. So you guys can always enroll with us for offline and online trainings with us. So kindly get in touch with us. So this is our VFD section. We have Siemens G120 VFD drives. So 1, 2, 3, several more we have. So these are our different types of PLCs on Siemens S7 1200, 1214, 1215, S7 300 PLCs. Then here we have something called servo controller, wherein we have practical applications made up here with the 2 servo motors. Depending on the commands given on this HMI, these motors can be controlled in 2-axis or 3-axis motions. So when you enroll with us for advanced course, we will be doing complete in-depth training on PLC controllers, VFDs, and servo system, and servo stepper motors, and then SCADAs, HMIs and all. So this is what is our setup. So we welcome you all to join our offline and online classes. So we are sure that you will gain a lot of knowledge with us, and we, as our logo says, we have a logo and a statement on it saying we always try to share the knowledge, and our motto is connect the university to industries. So when we do these trainings with us, we are 100% sure that you will do successful on-job working solutions. So we provide jobs also. When you enroll with us, we do the 100% placement only in automation domain. So do write to us, send email, or you can send a message on our WhatsApp. So we will be very happy to entertain your queries. So thank you very much for watching this series. The next series is going to be a comparison between Siemens, and we will take up Schneider or ABB or Rockwell. So we'll see which PLC. If you can tell us in advance, we can take as per your choice, Otherwise, I'll go with Schneider in my next session. Thank you and good luck for watching.